Okay, hello there everyone, and welcome to today's University Business Web Seminar. It's great to have you all with us. My name is Kurt Isley-Durley. I'm the webinar editor here at UB, and I'll be your moderator. The title of our webinar, as you see here, is Campus-Wide RF Solutions for Our Changing World, and is being brought to you through the generous support of our sponsor for today, Sennheiser. Today we'll be covering design and deployment strategies for large quantities of wireless microphones in a campus setting. We'll also learn from a case study of Sennheiser SpeechLine digital wireless implemented at Michigan State University. We're looking forward to an interesting presentation and discussion here, plus live Q&A. We welcome your questions, so do stay tuned. We'll get started in just a minute or two here. First off, though, just some standard housekeeping notes. First item, as it says here, for technical support, you can use the chat panel at the right side of your screen there. If you don't see that there, you may have to open that up by clicking the chat button at the bottom of the screen there. You can use that, again, for tech support. Just select the name of our event host and producer, Jason York, and let him know if you're having any issues. He'll be able to help you out there. Also, second item, as it says here, if you have audio trouble at any time, if you prefer to listen privately over the phone, we'll post the phone number and access code in that chat panel at the right side. You can dial those to get audio access at any time over the phone if you need it. Also, third item here, as I said earlier, we welcome your questions. You can feel free to use the Q&A panel, the bottom right-hand corner of the screen there. Feel free to type in your question at any time. We'll get to as many as we can at the end of the webinar. So once again, if you do have a question, type it in at any time in that Q&A, not the chat, but make sure questions go in the Q&A, and we'll get to those at the end. Also, the last item here on the slide, speaking of questions, we are commonly asked about accessing the content of our webinars at a later time, either the slides or the recording. And yes, we are recording here. And yes, just so everyone knows, everyone who registered or attended will be getting a follow-up email that'll include links to the slides as well as the archive recording. We'll have it on the UB site. So if you want to go back over it or share with anyone on your team at your institution, you'll have opportunity to do that later on, so don't worry about that. Okay, so with that, on to our program here. We have a great panel with us. Today we welcome David Missel and Chris Phillips, both work in customer development and application engineering at Sennheiser. We're also joined by Greg Kerner is Manager of Digital Classroom Services at Michigan State University, and Kenneth Fountain is AV Engineer also there at Michigan State. Chris and Dave are going to start us off here, and then we'll get to Michigan State later on. So with that, I'll turn it over to Chris Phillips from Sennheiser. So Chris, welcome to our webinar.
All right, thank you, Kurt. As Kurt mentioned, we're going to talk about deploying wireless microphones and RF across a wide campus. So that could be a university campus or a corporate campus. It presents unique challenges when we have to design for these systems and deploy them, but also manage them after the fact on a day-to-day basis. So we'll go through some basic RF theory, and then we'll talk about design and then management and go through some examples. So we're going to start off with just the basics of, let's see, there we go, the different components of a wireless microphone. So we're going to go through that and understand what makes these systems up. So the first part is often the most important part. The microphone is a transducer that takes sound waves and it turns them into an electronic audio signal that we're able to send over the air. This is really important. When you choose a microphone, it's important to make sure that you pick one that is good for speech in lecture and applications that are good for lecture and speech. Some are better for performance and some are better for speech, and it's usually listed by the capsule type on the website. The next stage in a wireless microphone is going to be the radio transmitter. So the transmitter is a device that is going to take an electronic audio signal and convert it into a radio signal that we can send over the air. We also need antennas. So these are the conduits that are either going to generate that RF signal or capture that radio wave. So there's antennas on both the transmit side and the receiver side. The receiver side, we see a couple different types here. We have a rack mount and a camera mount receiver. This is a device that is going to take a radio signal and convert it back into that electronic audio signal. So it'll be able to read it and parse it back together so you can send it to its eventual source. And then we have kind of a mix-up of the two, and this is a radio transceiver. And that's in systems where both the portable device, in this case it's a handheld, and the stationary device are always sending information back and forth to each other. And this can be especially helpful in systems where we need to manage them and monitor them and change different aspects of the portable device, whether that be the body pack or handheld, on a day-to-day basis for troubleshooting. So those are called radio transceivers, and they're primarily used in DECT devices, which we'll take a look at. So I'm going to hand it over to Dave, and he's going to talk about RF theory and kind of talk about the way that RF works over the air.
Thanks, Chris. Yeah, so we're going to talk about monitoring and deploying wireless systems across a campus, and on an IT level, how does that work? But we also want to think about how, if we're going to put wireless systems across a campus, how is that going to work in terms of the frequencies that we choose within the spectrum that is available? So when we think about radio waves, they're different from sound waves, right? We know that with sound waves, we need something physical for them to vibrate through to be effective. With radio waves, they are electromagnetic waves. They have an electronic and a magnetic portion of the wave, and basically they don't need a physical medium to propagate. They can transfer through a vacuum. And when we look at the spectrum of the electromagnetic waves, it's very, very large, and there's all kinds of technologies being used, of course, not only from wireless microphones, but in X-rays and gamma rays and the very, very high frequencies down to radio and where we're living more in the lower frequencies and a lot in between, including the visible frequencies of light and color that we receive with our eyes. But the important part about this is how can these different wavelengths help us or hinder us depending on how we want to apply them to our application. And certain frequencies are better for certain applications than others because of the wave propagation of them. So let's take a look at some of these differences here. So in terms of wave propagation itself, no, the next slide is okay, Chris.
Okay.
The longer the wavelength, the better it is to pass through or around certain objects that could be blocking that transmitted wave. So when we think about our lower frequencies and our most standard wireless microphones in the UHF range, they are considered a longer wavelength compared with the gigahertz ranges, which are much higher. They have a longer wavelength, and they can pass around and go through hard objects a little bit easier. So because of that, they don't reflect as much as shorter wavelengths do. So looking at shorter wavelengths or higher frequencies, they can reflect a lot more off of certain structures and create more multipath where you might be able to get more phase cancellations happening with shorter frequencies. So that can be difficult in some areas. And in terms of range, the shorter wavelengths or the lower frequencies require less power more power to push them. So the shorter frequencies, the shorter wavelength, the higher frequencies create more power to push them than the lower frequencies and the longer wavelengths. And that's something to think about too in terms of the range of that transmitted signal. If I'm going to cover a football stadium at a college and I want to have a ref mic or have a reporter's mic down on the field, I want to have a longer wavelength, a lower frequency, because I don't have to push it as far with less power as I would with a higher frequency or shorter wavelength. The same applies with cable loss. Those shorter wavelengths, those higher frequencies, we're going to lose more energy from an antenna through a cable to a receiver than we would with the longer wavelengths or those lower frequencies. And all this plays into how we're going to decide how to incorporate these wireless systems into our corporate environment or our campus environment. Same thing with antenna length. When we think about it as a manufacturer, with our Belpac transmitters, having a quarter wavelength on a lower frequency is a lot easier, and with the shorter wavelengths as well. Used to be we had the transmitters that were in the VHF range, and we had very long antennas, and that would go further down the leg perhaps to be really effective to match the wavelength that we wanted to transmit at. But the main thing here is to think about is how these higher frequencies with the shorter wavelength propagate differently from the lower frequencies that have that longer wavelength, and how we can make that work within our campus environment. So the next slide, please. So we can look at that in terms of the structure that we're trying to operate within. So a metal structure or underground can have a very highly reflective siding to it, so that we can expect a lot of reflection and probably a lot of attenuation as well. Because even the lower frequencies are hard to go through a metal structure. And this can really help us a lot in attenuating outside interference or attenuating RF getting out of one room into another room. So it's always good to take a look and see what the building is made of, or do some tests to see how much reflection there is and how much a signal within a room or outside of a room can travel through these walls or these different types of structures. When we look at concrete and masonry and stone, same thing. There's a lot of reflection going on there. When we start moving towards wood, drywall, or windows, then they do have some transparency in terms of attenuation of RF. And we'll see that there's a clearer path for them to go between rooms or maybe even between floors, depending on the makeup of those floors. Sometimes you can see a signal between ground floor and the third floor even, as opposed to even just one floor to the next floor. So it's good to test that and see how much attenuation there is between the floors. One thing to say about windows, most people will say, okay, so windows, it's very transparent for RF, and all RF can shoot through it. But not all windows are created equal. A lot of the windows will have some metallic tinting that's part of the window and can really attenuate the signal 30 or 40 dB, depending on the makeup of that window. So that's always a good thing to test. Just don't assume that if you have windows, you're going to have a lot of interference coming in. I've seen some windows that have really blocked a lot of interference from coming into a certain space. And of course, outdoors, it's pretty much line of sight for the most part in terms of interference. If you are going to have a festival or you're going to have an outdoor stadium, just be aware that transmissions happening there will travel pretty far and can get close to or inside of a building that may be nearby. So as you think about wavelengths, and as you think about wave propagation, think about the structure of the buildings and where you can take advantage of some of these buildings and how they can block RF and allow you to operate in a room without interference. All right, so let's look at some of these frequency ranges. There's a lot of different frequency ranges that are available now for wireless microphones. So the more traditional ones now, that's been going on for a long time, is the VHF and the UHF range. Both are really good wave propagation. The VHF has been around for a while, but not a very wide bandwidth, and it does have some DTV down there. The UHF itself is still a fairly wide bandwidth, going from 470 to 608 megahertz right now. The UHF range has gotten a lot more crowded, though, because of the transition of the 600 megahertz being sold off to the telecommunication companies. So you've seen a lot of broadcast channels come down into the 500 megahertz range. And we'll show you some scans showing that. So it has become more crowded. So we are looking at some other upper ranges now, and there's a lot of this technology that's available. The one that he did show you was the 941 to 960 megahertz. That's a STL band that's available for licensed users. Yeah, the one he just went back to, 941 to 960. Another one that is available now, and we'll talk more in depth about it, is the DECT frequency range, the 1.920 to 1.930. This is an unlicensed area, so you don't need a license for it. It's not a very large area. It's only about 10 megahertz wide. In Europe, it's 20 megahertz wide. But it does have some interesting features, one being that the technology requires it to be a transceiver. So your belt pack or your handheld is going to send audio signal, but it's also going to communicate with the receiver itself, and they'll talk to each other and set up frequencies automatically and gain control automatically. So it's pretty intuitive and does give you some nice power ratings up to 250 milliwatt and the ability to bring the transmit power way down to 0.3 milliwatt. In the UHF range, you do have some of that as well. Some of the belt packs and handhelds now and a lot of manufacturers, you can adjust the power of the RF of the transmitter. And we can use that to our advantage in both these technologies to really bring the transmission area down so we can do multiple classrooms. We'll take a look at that in a little bit. The other range to think about is the 2.4 gigahertz. We do have some systems in that range, but we don't try to do a lot of high channel counts in this range because it is a very, very busy spectrum in the 2.4 and the 5 gig range. And I think you all know that. You've seen the interference really come up as people use Wi-Fi more and more. Luckily, we've been hearing word of new spectrums opening up in the 6 gigahertz range. So we look to see more of that opening up in the future. I've been showing a website on the bottom here, just a really interesting website to go to. We try to keep up to date on all the countries in the globe and the latest frequencies that are available. So if you are from a different country, you can jump on that website and take a look and see what is legal in those different countries. Okay, so those are the ranges now. You're seeing some other ranges popping up in higher, in 8 gigahertz as well. But right now, this is what you're seeing as most popular in the wireless microphone range. Now let's take a look at the intermodulation, and I'll hand it right back over to Chris.
Thanks, Dave. So let's take a look at local sources of interference, and then also dig in a little bit on how the different technologies work. So one thing we need to take into account when we're using multiple channels of wireless microphones in close proximity to each other, within feet of each other, is intermodulation. So each one of these devices has an amplifier stage on the inside, and it's possible, if there's any people who understand music on the call, to generate interference frequencies by overdriving two transmitters close to each other. And we'll see this live in a second. This is called intermodulation, and they're similar to harmonics in music. The good news is we can calculate them, so we know where they're going to happen in these intermodulation products. And if there is some distance between the transmitters, 3 to 5 feet, they pretty much settle down, depending on what power you're using. But we need to take them into account, and it's something to think about, and we'll look at some strategies on how to do that. Let's take a closer look. I'm going to share my screen, and I'm going to put up a spectrum analyzer that I have here. Just one sec. I'm going to go ahead and run this, and I'm going to zoom out. So I've got two transmitters operating kind of close to each other. I've got a body pack and a handheld, and I have them at their highest power setting. And so we can see when I separate my hands, you can kind of see the two carriers, one to the left and one to the right there. And then as I get them together, we see these intermodulation frequencies pop up. this is caused by running these at the highest power. And in classroom scenarios, that's not necessarily the best thing to do. These are at 50 milliwatts. If I go into these and I set them lower, here we go. I'm going to set them down to the lowest power. We see that I can operate them fairly close to each other, and I really have to get them right next to each other for those intermodulation products to show up. And this is at 10 milliwatts. 10 milliwatts is going to cover, in most scenarios, if you have line of sight to the antennas, a classroom and also a lecture type environment. It'll cover that space well if you have your antenna system set up properly. The other thing with that is if you reduce your power in campus type scenarios, you're also not bleeding through walls. Since these are UHF microphones and lower frequencies, it won't bleed through the wall and impact neighboring spaces quite as much. So a good practice is to take your transmitter, walk the room, cover the antenna, and see how far you can walk and get it to the lowest possible power. The other thing I want to look at, and we're going to zoom in a little bit closer here, is the difference between an analog microphone and a digital microphone. So I have, right now, this is an analog microphone that I have in my hand here, and I'm going to zoom in on it a little bit so we can see the carrier a little bit closer. And then I also have a digital microphone, a digital handheld. And we can see it pop up there as far as its signal. An analog microphone uses frequency modulation. So any of these microphones for the FCC can take up 200 kilohertz of space in the spectrum and still be legal. So the analog microphone, we will vary its frequency a little bit, and we'll see this if I sing a tone into the microphone. We see the microphone modulate back and forth. A digital microphone, if I do the same thing, the one on the right, it doesn't change. And that's because even though RF is an analog medium, we're using a modulation scheme to send digital information over the air. So we use ones and zeros. So the silence in the audio signal takes up just as much data as sound does. So that's just a quick demo of analog and digital and intermodulation. I'm going to jump back to the presentation. We'll stop that. And we should be back at the presentation. Let me know if you guys don't see that.
I see it.
Okay, good. All right. So with that, we're going to talk about a third technology. We talked about digital UHF and analog UHF microphones. Let's talk about DECT, another range that Dave brought up. So this is at 1.9 gigahertz is the DECT microphones. So in the United States, we have 10 megahertz, which equal 5 DECT channels. It's a bidirectional communication, so it does take a little bit of time for them to communicate in the process. But the mobile device, in this case, we have a body pack here, and the stationary device, they're always talking back and forth, and we can get a lot of information from this, what its RF power is, what its battery power is. We can remotely operate the mute with a DECT system because it's a transceiver and it's bidirectional. The way that these systems work is when they automatically frequency coordinate as well. So we looked at the systems, the analog systems, and we know that we have to coordinate for intermodulation and things like that. In a DECT system, it uses something called TDMA, or time division multiple access. And what will happen is one channel will stand up, and as the other channels are turned on and activated, they'll check in with that first channel as secondary channels, and they'll automatically find time slots to operate in to stay out of each other's way. So DECT is an automatically coordinating RF system. The other good thing about DECT is its high frequency and the ability to change its power. You can easily contain these within a room. So as you're building a DECT system, it's important to get it similarly to the UHF system to the lowest power where you can walk the body pack around the entire room without it dropping out. With the higher frequency, if you set that power low, it's going to be contained within the room. Let's do another experiment with DECT. I'm going to share my screen one more time here. And I'm going to run a preset that's going to get us into the DECT range. And we're going to take a look at how it automatically coordinates itself. So open this. It's going to take just a second to build. I have some DECT devices here in my office in a rack here. And as soon as this populates, I'm going to start turning them on, and we're going to see what happens. On the right side, we'll see the spectrum analyzer, similarly like we did on the other screen. This left side is going to show us the spectrum over time. So it's a spectrogram, and we're going to be able to see the DECT activity as I turn different systems on. Don't quite see it yet. Oh, we got to run it. That's why. Here we go. All right, there's the DECT range. So now I'm going to start turning the systems on. We see the DECT range with not a lot of things going on yet. And I'm going to turn one body pack on, another body pack, and then two remote or stationary systems. We start to see them come on, and all these DECT channels start to come on, and we see them hop around. As they turn on, they communicate with each other, and it looks like the two of them decided to share channels of the 5 DECT channels. So what we can do here is we can, let's see if I can get a good pause. We can pause the system, and we see this little these little chunks of RF. So this could be audio information from a body pack, or it could be, you know, communication data from the rack mount receiver, but we can see it's using little bursts of RF to communicate that information rapidly back and forth. And that's how DECT works. It's an automatically frequency coordinating system. I'm going to stop this. And if you are setting up DECT, you can plan to set up a room with wireless systems, tune the RF so it's contained within the room, and then start with neighboring rooms and create zones of DECT systems that work together. So let me know if you see the screen again. I think you probably do.
Yep.
And we're going to move on. I'm going to pass it back to Dave for system planning and design.
Just a couple things to think about. You know, if you're going to plan a system, I mentioned this before, you really want to take a look at your local DTV. And here's a couple of different scans from a couple of different years before the transition from 600 and everybody moving down to the 500 megahertz. So this is just representing DTV channels, DTV broadcast channels, and they're each 600 megahertz wide. So these blocks are each a broadcast channel. So you can see it's getting crowded out there. But there's still some space where you can operate in the UHF. And with the latest in digital technology in the UHF range and the ability to bring frequencies very close together, we're still seeing ways of being able to do high channel counts in the UHF range. But you do want to take a look and see what kind of spectrum you do have available. And what a great resource if you go to this web page. This tells you who's broadcasting in your area, and it actually tells you what channel they used to be on in the 600 megahertz range and what channel the broadcaster moved to, and where their antenna is as well in location to you. Really great way to see what kind of interference might be able to reach you. And just because you see a broadcaster TV here, if you were in Tampa, you should definitely still look and do some scans and see if that transmission is getting into your building. Because as I mentioned before, really matters what that building is made of and how much of the building is going to attenuate that signal coming in. Okay. So one of the first things in that regard then is let's do some walk tests and see what kind of buildings are made of, what kind of transmission I can get from one room to the other. If I do have an outside performance area, Maybe I'm going to have 30 or 40 channels of UHF here for this outside performance area. Is that going to be getting into the buildings here? And if so, would I have enough UHF spectrum to have it be available to do classroom technology there too, or do I want to move to the DECT technology and open up some space for UHF to operate multi-channels over here? So this is stuff that we can look at by doing scans, doing some walk tests, and seeing what interference there is in the area. And then there's always pre-coordinated frequencies. If you do see where there is some space, a lot of our UHF devices all have pre-coordinated frequencies, and it gives you a pretty good view right away after doing a scan with our own receivers, because they all have internal scanners, to see how many channels you can get within a certain space of spectrum that you do scan. So that's just something to take a look at, another tool to find out what kind of interference is in the area using your receiver, your microphone receiver, as a scanner looking at the spectrum. And then there is monitoring coordination software. As Chris had mentioned, you do have to be aware of intermodulation in the UHF range with a lot of devices. There are some devices that are better at not having intermodulation as others, but it's good to have some coordination software on hand. We have the wireless system manager and our SIFM frequency manager as well. Looking at the DECT technology, that's going to do its own frequency management itself. All right, so let's take a look at a quick scan with a receiver that Chris has.
Yeah, I'm going to pop it up here. Hopefully it pops up. Okay, and we'll start a scan.
So if you did have a scanner, and maybe you had one of our devices, and again, some of the other manufacturers have this too, so this is a good way to kind of take a look at the spectrum, and you'd be scanning the spectrum of that receiver. Now, the one that he's scanning with is a 6000 series, and that covers a wide range of spectrum, but it gives them a really good look at what's happening where he is, which is in Minneapolis, out of the two antennas that he has on the receiver. So taking a look at it, you can see one thing to think about. In the U.S., most of the public safety type of transmission, for emergency response, first responders, is down in that 470 to low 500 megahertz range. So you do want to look at that, and we may be seeing some of that right here with these spikes down below. If you did the same scan in LA, very, very busy down in this area. So take a look at that when you do scan your area and see what kind of interference or activity you're seeing down below. Now, one thing that's not good about this type of scan is a one-time scan as opposed to a real spectrum analyzer that's constantly refreshing, but still a good tool for you to get a good look at what your system is seeing. And then up here, we're seeing the long uplink and downlink of the telecommunication companies up in the 600 megahertz range, where we won't be able to operate in anymore come July. And there's a big swath of noise here, and then another swath of noise right here. Okay, so a good tool that really get an initial look, especially if you're putting it through your remote antennas, to see what they're looking at in your venue.
Cool.
Okay, so that's the receiver scan. A couple of tools just to think about if you are looking for a scanner. RF Explorer, very inexpensive, not the best refresh rate, but boy, it does come in handy because it is portable. The Signal Hound is another one that plugs into your laptop, and then we use the Tektronix at Sennheiser quite a bit. Really good resolution, a little bit more expensive, obviously, but really good refresh rate and pretty good clean noise floor with it as well. And then one thing about system design is RF cable. When you look at the RF, I mentioned this before, we really want to think about the frequencies we're using and how that's going to relate to the length of cable we're using from our antennas to our receivers. This is a chart from Belden. It really gives you an idea. Always remember, use 50 ohm cable. The other thing is RG58, you see it out there a lot, is fine cable, but really for RF and long lengths, very high attenuation. Even with 100 feet, I'm losing 9 to 12 dB, depending on the frequency range. We usually recommend, especially for installs where you're going to put the cable in and forget about it, you do have to do a long run, 25 feet or over. Let's see if we can move to like a Belden 9913. There's other cables out there like LMR 400 and so forth. but it's always good to use a high quality, low loss cable for UHF, and especially for the high frequencies like the DEC technology that we're talking about. Very high loss at those higher frequencies. It can be double what we're seeing here. So always try to keep the cable lengths short if you can, or for classroom technology, if you can, receivers in the classroom if possible. All right, so let's take a look at a couple scenarios. And Chris is going to go through this in setting up a classroom technology with UHF, and then the differences between that and DECT, and how they can work together.
Yeah, so let's look at some common scenarios where we have classrooms right on top of each other or right adjacent to each other on the same floor. So frequency coordination if we're going to look at a building, we'll say this one is partially transparent. We want to look to avoid the intermodulation 3 products, and those were those 2 big spikes on either side of the main carriers. You could do that by using the pre-coordinated frequencies that are in the system. So our systems, we call those banks, and those are going to be intermodulation free as far as their calculations. We want to reduce the transmit power. We saw what happens when we reduce the transmit power and what it does to intermodulation products. It also, in a lot of cases, can mean you can double up frequencies or get frequencies close when you're several floors apart with the UHF system. So reduce the transmit power to the lowest amount that works in the whole classroom, but allows you to works in the whole classroom that the transmitter allows. And then localize the receiving antenna. So a DECT system may have an access point looking transceiver that goes on the wall or a rack mount device. A UHF system, if you have a centralized rack, you may need to go back to that antenna cable that Dave was talking about and do a cable run. So when you're localizing them, be careful about your antenna loss. You want to make sure you don't have more than 6 dB of loss in that scenario from antenna to receiver. So let's look at an example. We have, we'll do UHF first. So we have 2 rooms right on top of each other with a partially transparent floor. Room 211 has 2 channels of wireless, and room 111 has 6 channels of wireless. These rooms on adjacent floors, we can do an auto scan and find that in our bank systems, you always want to stay within the same bank, don't mix banks. We have plenty of banks that have more than 8 total channels, so we're able to create a system that is fully frequency coordinated between these 2 floors by staying within the banks. With the DECT system, we want to, because it's higher frequencies, it's easier to contain those within rooms. So we know it's going to automatically frequency coordinate. We don't necessarily have to do the auto scan. We just need to reduce the transmit power so we can walk the entire room to the lowest amount with the walk test. What we end up doing there when we do that is create 2 zones that are independent from each other. So the DECT system, it's really dependent on your walk test. You don't want to set that power too high. You want it to be a zone within itself. So let's add another 8 channels. Now we're going to add another classroom on an adjacent classroom on the same floor as 111, which needs 8 channels operating. Let's go back to our UHF system. And what we find in that scenario is we don't have 16 total channels in any of these banks to make it work. So we could use software like WSM or SIFM to create a custom frequency coordination, which will work pretty well. Or an easier solution might be to find another frequency range that has some space. So you're using 2 different frequency ranges on the systems and their tunability. And that allows it to be a little more diverse, and it gives you a little more headroom. So that's what we did in this scenario with UHF. The 2 rooms on top of each other, we kept them at 470 to 558, and then we picked a different range, 554 to 608, for the new room, and we're able to get them all working together without doing a custom frequency coordination and just using the banks. With DECT, it's very similar to the first one. We just create zones for each of these systems. So we zone it out. So the last thing, the next part, and we're really excited about this, we're going to pass it over to our friends at Michigan State, who have done some pretty large deployments with wireless microphones for a long time, and they're going to talk to us about some tools for management for wireless microphone systems. So I'm going to pull up your slides. I don't know if we could transfer it over to Ken to drive.
Okay, thank you, and obviously I want to say thanks to David and Chris. Did a great job on the technical background on that, and thanks for inviting us. So if you want to go to the next slide there, or actually you passed it along to me. So just to give a little bit of a background on what we're doing at Michigan State, as you can kind of see, it's a pretty big campus. If you read some of the specs that are within that, 5,300 acres, and for those trivia people, technically the campus has a little over 20,000 acres, but a lot of that would be agricultural land. 563 buildings. You can see a little over 5,000 faculty and staff supporting the faculty. I broke this slide up into two pieces, again, just to kind of give you an overview of what's going on with us. There's client services as well as AV-IT integration. I'm in the AV-IT integration portion. Again, this is Ken. And that kind of gives you kind of an overview of, at least from our standpoint, as the size and of the campus, the amount of equipment, and the minimal amount of people that are actually supporting the systems. With that, Greg on the other side, he is the manager for client services. If you want to say hi, Greg, and kind of give a little overview of what you guys are doing.
Yeah, sure. So we cover about 380 classrooms, and then in addition to that have support our professional colleges, a couple of medical schools as well in there. So that's what we are. That's what we're working with.
Yep. And so as you can see, I mean, and in the size of the campus, as opposed to clearly the minimal amount of people to support it. Technically, I mean, we have 3 AV technicians. Our teams actually work together really well. At some point in times, previous past, we've been one group. But as you know, just with universities, things change here and there, but still closely related, where a lot of the first response will go to Greg's team, tier 2, tier 3, and obviously the installation actually goes to the integration team. I'm throwing this out here, and some of the pictures, as you can imagine now with some of the social distancing and things, these were some of the older photos we had of the tech carts and things. So I can throw some fancy rooms in there right now just because of the current situation. I broke this up into several different locations, and I'll elaborate slightly on the next slides. Within rooms like this, or as you can see, I mean, there's roughly 500 wireless mic systems on campus. Clearly, classrooms are a big portion of those. Stadiums, ultimately, there's about 25 varsity squads on campus, so lots of different venues for that. Press conferences, our group also supports press conferences for the athletics and whatnot. Conference rooms and live events. I'll start with the classrooms. Kind of like Chris was saying too, is this is just a quick diagram of one of our buildings that we have. If you look down on the far right corner, it actually shows you that this is basically a section of one of the buildings. So technically there's 4 sections, and this is one of the wings that we have. And if you can imagine, if you look at it, just within that one wing, there's several classrooms that are right next to each other. And being the fact that this is actually 3 floors of identical room spacing up and down, the nature of, basically coordination of frequencies kind of a really large deal. And I can't say enough about documentation. Obviously, you know, spectrum analyzers and things like that. We're very fortunate because we do have someone on campus through telecom that will help because we have a lot of research facilities and things too that will help coordinate our frequencies. But again, like both Chris and Dave were saying, it's a lot of coordination with frequencies, and I would be lying if I had said at some point in time somebody in this classroom over here was hearing a you know, a phantom voice in another class going on, and it was the nature. I mean, you know, you're usually concentrated on your basically your presentation more than technology, and sometimes faculty, you know, they'll accidentally change a frequency or something on their microphone, and that's actually what's kind of a nice thing about working with like DEC systems and things that will auto coordinate that or you know, bump around frequencies, so you know, that alleviates some of that. Something else I'll bring up, you can see over there like wireless mic. Obviously, accessibility is a big thing for us at Michigan State, and we have a group that works with us on that. Something that you see, these are about 50-person classrooms, you know, within each one of these tiers here. And the fact that a lot of people question, you know, why, you know, would you actually need a wireless mic within one of these systems? In our current situation, you kind of understand that particular portion, but we've been putting in, again, UHF, DEC systems, basically 2.4, we worked with those as well. And the necessity of wearing that wireless mic so that basically we can pass along information to the FM modulators for like hearing impaired, hearing assistance systems that we have in each one of the classrooms. Also, closed captioning. A lot of the devices are actually some of the distance learning and things that we do at this point require that. So essentially not just for voice reinforcement, but sometimes even the speakers will actually be turned off. They'll be wearing the microphone, and that information is actually sent along to the group that needs it. And as I mentioned, you know, the virtual classroom, that's kind of huge right now. With that, I mean, our big challenge, and I think that's something that everybody looks forward to, is, you know, that single pane of glass, basically meaning monitoring and whatnot. We've, as I mentioned, with several different systems, we've tried pretty much all of them on campus. And I'll let Greg on this next slide here actually speak to something that, you know, if he wants to touch on as far as what we were doing previously, as opposed to some of the interesting single pane of glass that we're trying to get to. So, Greg, if you want to speak on the system there.
Yeah, sure. So just a couple of things of note. So when we're dealing in about 380 classrooms and each one of them having at least one microphone in them, you can imagine the amount of AA batteries that we simply would go through in any given day. And we would run students out to some of our student employees out to these various rooms to either make the swaps depending upon the class schedules, or, you know, leave behind some batteries, you know, behind so that folks could, you know, make the change on the battery themselves, that kind of thing in a lot of those spaces. But as we moved to the Sennheiser SpeechLine product, what we were able to do was move to obviously the charged microphone model. And this has allowed us to cut down by about 90% the total amount of calls that we take related to microphones to classrooms, this is a tremendous help when you see, you know, our full-time staff size, you know, plus our students, that, you know, being able to monitor and to know when we might have a problem in a classroom, or you know, when there could potentially be an issue. So generally speaking, Monday through Friday, in normal times, what we have is a student crew in the evenings who are monitoring through the Sennheiser cockpit, looking at, you know, where we might have maybe a microphone that was left off the charger, or we're starting to see potentially a low battery issue or something like that. So the students will go out there, they'll make sure that the microphone is put back into the charger, everything is looking okay, and they'll and that's kind of a part of our evening cadence. Now, some of our classrooms are located in residence halls, and residence halls are managed a little bit differently. So then in the morning, our first FTE in the building, basically, he'll go in, check cockpit. Are there any rooms that I need to go either swap out one of the batteries on, because the amount of time that it might take to charge up isn't going to be, in time for the first 8 a.m. class that happens in that room, or conversely, that he's just going to go in and make sure that everything is charged up and ready to go for those rooms. So you can see down here on the bottom spot where we've included a screenshot of kind of the charging bays. Because the 4-port charging bay is all networked, we're able to tell what the battery health is and what the battery level is for all of these rooms, kind of across campus. And we found that to be, tremendously helpful. As we try to be more efficient and have our technicians solving real problems as opposed to kind of trying to take care of batteries all around things. So simply the amount of time that we've spent to reduce our activity in some of these rooms and reducing interruptions, everything across the board has been a tremendous help for us using the speech line setup and the control cockpit. One of the other things that I also wanted to mention is when you have a large institution like this, microphones walk out of the rooms. Faculty are wearing it, they take it, it disappears, something like that. And what Cockpit is able to do is it tells us exactly the right time when the microphone left the range or essentially left the room. And so now we know when we look at the class schedule, who do we need to target to go back and get this microphone from? And, for the most part, we've had an incredible return rate on these that we can, rather than emailing, the entire swath of everybody who's taught that day, we can target and pick down right down to the exact faculty member who most likely walked out of the room with this. And then we get the microphones back, within a couple of hours or almost immediately, as opposed to, sometimes where it would be another day or two and we'd have to go in and install a temporary microphone. Or even a wired mic in some situations. So where we've been and where we've gotten to has been a tremendous improvement.
Thanks, Greg. So in addition to obviously what Greg had mentioned, which I personally know, that has dramatically helped within the campus as far as monitoring and whatnot. There's another side to the administration of the systems too. This is actually, again, a fairly new tech cart. We do actually have a division on campus that builds our own tech carts. And if you actually look within up the front, right next to the touch panel, this is actually one of the charging systems from the 1.9 system that we've actually integrated right into the tech cart system. I'll touch on that in a minute, but a couple of the bullets on the side there, live support, exactly what, or I should say in addition to what Greg was saying. There's functionality. I'll go back to someone who's actually speaking and all of a sudden it cuts out. We have a help desk that could be contacted with that. If it isn't something that Greg's crew was unavailable or something, we can log in remotely, and things like if they accidentally mute the mic, well, we can see that, we can unmute it, and minimal disturbance to their class, which has been a great benefit. I put the network portion on there because it's another benefit. The nature of the way the system works is the charging system is actually on the network. So if the network goes down, we can see which one of these rooms is, not functional and work with network to get that situation taken care of. The nature of everything in the world now, firmware, everything needs firmware. We are a control system based university where we do use things, some other collaboration things with like Fusion and whatnot. We'll actually we'll be able to see what's happening in the rooms, but firmware updates. with something like this, we can actually just push it, and away it goes, and that's actually a handy function. I put the maintenance items for inventory too, kind of like Greg said, in the fact that we can see the percentage of those batteries as far as not only that, but life cycle. So if we need to change one of those out or something, we have an idea, keeping spares, taking them into the rooms and things like that, has been a big advantage over, kind of doing the analog way there. And again, just background, we have wireless mics all over the place. So we, suffer with challenges with the FCC too, with, changing out frequencies. When we came across the decks, as I said, we've worked with the 2.4 as well as UHF. Stadiums, there are some things that for vocals and things like that, we still maintain UHF systems. The sporting events, as you can imagine, we're basically giving live feeds to the TV broadcasts. So there's a big need for dependability and things like that, which the wireless has worked great. Headsets, the ref mics, giving feeds to the press. Always interesting. That's why we go back to why we like functionality of being able to see what's happening in each one of those mics, because when you have 120 mic systems at some type of sporting event, as you can imagine, there's huge coordination between what those mics are. We have lists that actually go out to the broadcasters. This is your frequency, but there's always that person that will walk in. They've always had their mic set at that frequency. They forget about it, and impending on basically other frequencies, which there's backup microphones and things for that purpose to just in case, until we can track down who that person is. Press conferences again. Same thing. We can have multiple, wireless mics for each player that's going through the press conference with it, radio feeds, and it's all kind of combined with that. The last thing I touch on is the conference rooms and the live events. Is again, I'm sure similar with other universities. We have tons of conference rooms. We do board meetings, which will have multiple wireless mics out there. Basically, some unique cases when we do the board meetings. Same thing. We're actually feeding the conference system from those wireless mics into any type of conferencing system. We support most of them. And then kind of the last thing I touch on is live events. Live events for us, and Greg can attest to this too. We're the ones on campus that we'll get a call and we need somebody in 3 hours to do the special event or something, and anywhere from 3-4 people all the way up to 25,000 in a stadium or something, where the fact of having to set up each one of those wireless frequencies, as you can see, we could technically, we typically don't do more than 24 wireless mics, but up to that amount, and the coordination for those frequencies. And back to the fact that how nice is it if we could have all these microphones coordinated so that there was minimal amount that we needed to change. So just as a case point, going back to how nice it's actually been to have an online system too, that we can work with that. So I think that with that, thank you.
Great, thank you, Ken. Appreciate you being with us, and thanks to the guys from Sennheiser, Chris and Dave as well, and Greg and Ken. Yeah, we just have about a minute left here, but I'll get to some questions. Again, if to our audience, if you have any questions, just enter it in the Q&A, bottom right-hand corner there. Let's see, first question, Dave, go to you with this one. How many decked microphone channels can be used together in one room?
Yeah, that's a great question. So with the DECT technology for the Sennheiser system, if you are going to put it into a single room with multiple channels, you can go up to 8 channels only. So it's really for the application of 1 or 2 channels per classroom, and the reason being is it is a small spectrum that's allowed in the U.S. Right? We're talking about 10 megahertz. So in one room, you wouldn't want to go any more than 8 channels of the DECT wireless microphones.
Okay, sure. And next question, interesting one. Ken referred a couple times to how things obviously have changed here during this pandemic and social distancing. Someone asked about what about using plastic face shields, things like that. Does that affect your microphone placement or how you would use some of these wireless microphones? Maybe Dave or Chris, do you have, from your perspective at Sennheiser, do you have any recommendations there?
Yeah, so if the microphone is behind the face shield, it'll be in contact with anything that might become transmitted as far as COVID goes. But if it is on the other side of the face shield, it's gonna sound a little bit different. So some of the high frequencies from the voice are going to be reflected off the face shield, but it still should be usable if it is located outside of the face shield. With that said, we do want to, when we're using wireless microphones, take good care in cleaning them. We're looking at different ways of doing that, and we have a link which we can actually put in the comment section. I just have to find it on our website that talks about how you would clean and do your best to sterilize microphones, which do come in close contact with mouth. What we see a lot of folks doing to get around this is have multiple microphones where a professor might have their own lavalier or headset microphone to get around that in the short term, why COVID is a concern.
Okay, sure. Yeah, it's certainly affected every area of campus life here. A question for Ken or Greg. Someone asked, what's the most common interference that you encounter in your classrooms when it comes to wireless?
Greg, I don't know if you want to take that or not, but I would mention when you say common interference as because of the coordination of the frequencies, it's not often, but kind of like I did mention is there often it's somebody changing a frequency and jumping on that same frequency somewhere else. So more of an accidental thing. Occasionally, because as I mentioned, we being a research facility, there's some places on campus that are actually on a range. I was thinking of some of the FRIB locations and things that we have, that they have some unique systems that basically they're using within those open ranges. That's very uncommon, but I definitely would say mostly it's accidental where someone's jumping onto it. Bringing up once again the fact of it's nice if the systems that we have now that will coordinate and move around what they need to. So.
Yeah, and I would just echo the sentiment of since we moved the large majority of our classrooms to the Sennheiser SpeechLine, the microphone that may jump to the next classroom or something like that has happened far less frequently, because we know when something leaves the zone or leaves the range of the receiver, and so we can go back and get it and bring it back and plop it into its right spot more often than not now. So that's actually reduced the amount of panic or incident calls that we have, and we really are able to focus a lot more on resolving requests as opposed to incidents now.
Just to touch on the frequencies and what to look out for interference in the DECT range in that 1.9 is an unlicensed area, but most common use of that is the call center headset technology for making phone calls. So just be aware of anything that's close by. It doesn't transmit far, but just something to be aware of. That's usually what we look for first, is any local call centers that are nearby, which is not usually the case for a university, but we particularly look on a campus corporate environment for that.
I would bring up too the fact that again we're very grateful for DECT. Let's say that, because I think it was mentioned earlier about 2.4. We did originally when frequencies were moved around, working with 2.4, and just for everyone else, I mean it's typically on a Wi-Fi frequency, which can cause some severe interference depending on it's a university thing, so.
Sure. Yeah, of course. Okay. Well, thank you so much. We've gone a little bit over time here. I just want to be respectful of everybody's time and wrap things up here. On behalf of all of us here at University Business, thanks so much to our speakers for today. Dave, Chris, Greg, and Ken, thank you all so much for sharing your time and expertise with us. Thank you again to our audience. If you didn't get your question answered, we'll gather those questions and someone can follow up with you later on. Thanks again to our sponsor for today, Sennheiser, for their generous support of our webinar. And again, to everyone in our audience, thank you so much for joining us. I hope you found our webinar informative and useful to you. Producing events like this one is just part of our mission here at UB, to inform college and university leaders like you about the latest news and trends in higher ed management. You'll find more coverage about issues such as the ones we discussed here in the pages of our print magazine, as well as our digital edition and website, through additional webinars like this one, and through our various e-newsletters, which include UB Daily and UB Tech, among others, which you can sign up for right on our website. And as I mentioned before, for those of you who would like to share the content of this presentation with members of your team at your institution, or if you want to go back over it at your own pace, the archive recording will be stored at the URL on your screen here. And again, we'll be sending out a follow-up email to everyone that'll include links to the slides as well as the recording, so you can access that later on. So that is it for today's event. Once again, I'm Kurt Isley-Durley for University Business. On behalf of everyone here on our production team at UB, goodbye everyone, and enjoy the rest of your day and have a great summer. Thanks so much for joining us today.
Thanks, Kurt. Thanks, everybody.